Look at us.
Hello, Darko.
Hello, Julian. How are you doing, my friend?
Yeah, I have this intro I normally do, but I'm not really meant to be doing it today because you're the host.
Oh, yeah, I'm the host.
I know.
Hello, everybody, and welcome to the Serverless Office Hours. My name is not
Darko's
Julian Wood.
I love it how we've turned the tables and Serverless Office Hours. Yeah.
Indeed we have. Well, thank you so much for having me, Julian, here. And for the folks in chat, hi.
No, thank you for having me.
Oh, yeah, and to the folks in chat, welcome to the Serverless Office Hours. My name is Darko, and Julian has me. I have him over on the show today, and we're going to be talking about some wonderful enhancements to the developer experience of AWS Lambda. I'm going to kind of be hosting today's show, so I'm going to be the pretty face. Well, Julian is going to be in the driver's seat.
I'll be the not pretty face. I'll make that show, yeah.
So Julian is going to be actually showing us some cool things. So if you are interested in some serverless development, if you have been dipping your toes in Lambda functions and you've been thinking, well, this could be better. Well, we have a couple of things lined up for you.
To talk about, yeah.
Absolutely.
Yeah.
So,
but just to kick it off, because AWS is crazy at the moment because it's 2 weeks before reInvent, and so there is, it's basically called pre-invent season, where a huge amount of stuff is just coming out. Now, I even get lost with the whole kind of thing, so I thought I would just stick together a little bit of a list. But also, remember, we're live, so send us your questions and your comments. We'd love to hear where you are. The Dark always appreciates the good things spoken about him. Absolutely. Because he's awesome. So yeah. So just going down the list, literally like DynamoDB. Well, first of all, the second one, I should have put that at the top. DynamoDB half price, like literally reduced prices for on-demand throughput and global tables, literally 50% off. You don't have to do anything. That's just done. And then, that is amazing. I didn't even know that one was happening before it's come out. Absolutely brilliant. If you do using DynamoDB, it just changes that thing of, am I going to use provisioned or on-demand? It could make that easier. And the top one, attributes access control, always helpful if you're going to be doing policies at scale. And then warm throughput tables and indexes, just a sort of performance boost. And then I would love to find out which is the customer that requested up to 1 million Amazon S3 buckets per account. I mean, that is awesome.
So I've been personally struggling with the amount of buckets I have in my account. So at this moment, as we speak, I have 148 buckets, and my limit is 150. And every once in a while, I have to do a demo which creates a bucket. I'm like, okay, cool. Let me find buckets I don't need and delete them. And I don't even know how to increase my bucket capacity over 150 these days. But now you can do a million. Of course, friends, it's not enabled by default. You have to request to go to 1 million. I'm sure somebody's gonna ask you a question. Why 1 million? But you can have 1 million buckets, I guess.
I suppose maybe for a SaaS provider and you're doing different buckets per different customers or that kind of thing. Naming's going to be interesting since they have to be globally unique for all customers. Maybe not. I suppose if they're infinite names, but
so that's a future problem, right? But I wonder, so because we're dealing with something that's definitely globally unique, right? And we have millions of customers, and not all of these millions of customers have millions of buckets, but if we reach to a huge scale of buckets, they would have to use some very arcane UUID generation to be able to safely determine if this name is not taken or not.
I wonder what a hex value for 1 million is or something, because you'll have your account ID and then you could prefix it with the account ID or something. So anyway,
true.
So
okay,
if that helps you, good on you. Step functions, you can export infrastructure as code for step functions templates. Awesome. And then Event Bridge, 94% improvement. That wasn't in one day. It's sort of over a year and a half. But anyway, this is there's a whole actually massive big story behind this. And in fact, I'm doing a reInvent talk, which I'm introing onto about this, because everyone thinks, async, that's that slow kind of thing. Backend processes, blah, blah, blah. But if Event Bridge is 94% faster than it was a year and a half, 2 years ago, you could send messages using the new AppSync Events API, nothing to do with GraphQL, just a WebSocket, through Event Bridge in 50 milliseconds. I think that'll be fast enough. So basically, sync looks like async, opens up a whole new world of awesomeness that you can build. And it's just actually quite simple to implement. So really interesting architectural pattern.
I must say I've been using it. I'm using EventBridge for the last year, and it's become my favorite service. I think it's just the fact what it can do, and the fact you can how much you can integrate stuff with. It's just great,
Yeah.
great.
Yeah.
I
And it's
want to say
hard.
hello to folks in the chat.
Yeah.
Hola, one ALRX. Welcome to the show.
Thank you very much for joining us here. And then you have ECS in the container world. Service versioning and deployment history is also there. Darko Renato, who is one of our software engineers. In fact, what we've been talking about today, Renato built some of it. So, but he says your volume is a little low.
Ooh, okay.
So.
I'm gonna try to bump up my
Thank you,
volume.
Renato.
Thank you, Renato.
You see, testing and production. Renato knows exactly how that all works. He's giving live feedback, improving the audio experience.
Absolutely.
Okay.
Thank you.
Time is going to go. So let's Lambda. So Snapstart for Python and .NET functions came out yesterday. And what is Snapstart? It basically dramatically reduces your cold start times without you having to do anything. So you basically turn it on. People are going, why Python? Python's really fast anyway. .NET not that slow. Well, Python can be slow if you are going to put a whole bunch of ML libraries you maybe want to download, or something that you want to download from the internet, or you want the people running DuckDB or pandas, or all these kind of things. They want to do a whole bunch of setup in their initialization phase and then be really fast. So Python normally super fast, but there are some new cool things that you want to maybe do in Python. And so basically you run the init process and create a point-in-time snapshot, which is then saved to disk and distributed all around the globe in a cache. For .NET functions, because .NET has sort of just-in-time compilation and assembly loading and all this kind of stuff, once .NET goes, it is super fast, but you want to sort of crank it up and get it going, so you've got a bit more control over that. And then, next time your invoke comes in, it does a restore, which is under a second. And so, some .NET functions, you got a whole bunch of stuff happening, could be 5-6 seconds, and now it's under a second. That is awesome.
That is amazing. It's I think it's one of those great features that, like, having it be faster and just kind of speeding up and like, I think somebody was, why is there no JavaScript? I think somebody mentioned, like, why not JavaScript? I feel like that could be one of those, because it's the most used framework on Lambda, I would assume.
Yeah, it is. Two reasons for that. One is a use case reason. And the use case is because Python is using a whole bunch of machine learning stuff, the package sizes in Python are generally much bigger than Node. So no JavaScript, TypeScript, because it comes from a sort of front end history, there isn't as much of the use case. You're not running a massive database in memory that generally on Node, one version. So that's one part of the story. The other part of the story is, behind the scenes, there's a whole sort of question about uniqueness, because you create a snapshot of a function and you restore it. What happens about number seeds or database connections or all those kind of things? And Lambda has specifically made a choice not to do anything bespoke to Lambda. That's a good thing. So there are lifecycle hooks as part of .NET and as part of Java, and they've introduced a decorator for Python to do just that. So it means that when you restore from a snapshot, you can redo things very quickly. That's not quite on the uniqueness thing, but also there are specific libraries in Java, Python, .NET, which are secure for a randomness perspective. It comes back and goes, oh, I've been restored from a snapshot, and will regenerate its seeds. That's safe. I'm not quite sure if that's not quite available for Node yet, but that is the reason that Python and .NET took a little longer, because we're sort of waiting for the languages to be able to support those natively, so you don't have to do something weird just for Lambda.
That's really good. Hey, faster Lambdas. That's always good.
Exactly, fast Lambda. And Python 3.13. That's that also came out recently as well. So if you're doing that, that's just another version upgrade. The cool thing about this is, I'll quite happily admit that Lambda was getting a year or two ago, Lambda was getting a little long in releasing all these language runtimes. There's a good reason for that, because there was a whole bunch of stuff going on behind the scenes to speed that all up. And this is all happened now. And so Python 3.13 literally came out, I think it was 37 days after the official release. So 37 days after official release, in production, ready on Lambda, because we don't put things out in Lambda that aren't ready for production. So we've had a container image for a while. You could mess and play around with it. But this is ready for production in 37 days from release. Good work. I know the Lambda engineering and PM teams, worked hard on this over many years, and that has paid off.
Amazing.
Just down the list, .NET for JSON logging support. Yes, so just better JSON logging. And in the bottom four, I'm actually going to go through all of that today. So, improved IDE experience, nicer, fancier console, log analytics with the live tail, and a built-in CloudWatch Metrics dashboard.
I must say these these last four enhancements that you're going to be showing us is, for me, as somebody who hasn't grown up with Lambda functions, I haven't started building Lambda functions when they came out and haven't been all introduced into that world early on. As somebody who's kind of just dropped into the middle of it, I find it always super convoluted to build applications that use Lambda functions, just because of the development experience does not really replicate anything local, like testing and all of this. Finding out the problem, you have to deploy a Lambda and just look at a log. Oh, it's broke. Try it again. There was a lot of the shift left wasn't really that good. So
definitely.
I'm excited to see these.
No, definitely, and this is part of a journey. And there's there's a big team within Lambda who look at the console and look at tooling and IDEs and SAM and CDK and all these kind of things. And and also at a higher level of what does developer experience mean for serverless, across the portfolio, specifically for Lambda. And so there's a big remit and a focus at the moment of trying to make that part easy, because Lambda does a lot of awesome stuff, but definitely some of the onboarding, if you don't know it to understand it, they're just some understanding things which we trying to help out. So I'll go through that as well. But obviously this is all building up to reInvent in 2 weeks' time. Darko and myself will be there. So yeah, if you're going to be there, please come and say hi. It'd be awesome to talk about serverless stuff.
Absolutely.
So why don't we jump on to doing any demos? And I just want to say that, first of all, that there's been a huge engineering effort behind the scenes to do all of these IDE enhancements. And Renato, who was, earlier talking about the volume, is just one of a big team. And I've been, very lucky to work with a whole bunch of people to put some of these together. So yeah, I'm showing off the stuff, but there's an awesome bunch of dev teams. And what's cool about this is, it's across a whole broad range of AWS, from consoles and CloudWatch logs and VS Code and language runtime kind of things and UX designers and all that kind of thing. So it's cool to see, the focus in AWS. When we talk about two pizza teams of being very narrowly focused to do the right thing, it's very cool to see how broad the input has been and the work has been on this, which is always cool.
I must say that it has improved dramatically over the last, even just a short amount of time. So very, very happy to see all of these things.
Definitely. Darko, is my console big enough, or do I need to go?
I think it looks good. I'll have the chat also scream if it's not good.
But, yeah. Let me know.
Versace Dribs is here. Says inline editing for .NET and Lambda. Oh my god. Yeah. Great.
Yeah. There we go. Yeah. So we'll explain some of that as well and how that kind of works, which is super good. And now to get your in-house devs off .NET framework, Crysis EC2. Yep. Yeah. .NET Core is looking good.
Yeah. Awesome. Let's show me what you got.
So I could have created a new function, but I've got an existing function which is here sitting lovely in my AWS account, which I've very cleverly called Lambda New Console. And just in case I didn't realize, I'm being told you are using the new console editor. So if I scroll down here, this is what it looks like. And deliberately, it looks like VS Code, because it's actually using the Visual Studio Code open source version, which is called Code OSS. So obviously, Visual Studio and Visual Studio Code are the sort of brand names for the local development environment, and the Code OSS one is the open source version, which basically runs in a browser. And this is cool because my local browser looks a bit similar. I'm used to having things down the side. I'm used to looking at the file things over here. I'm used to having some extensions, debug, all these kind of things. It looks the same. It looks the same, and that is also cool. And I'm used to having the console on here.
You can also go into full screen, which is kind of fascinating.
You can go into full screen.
There's a full screen button, and look at that. It's an editor now. So.
Good one.
Wonderful.
We can even stick in full screen mode. Yeah. Actually, I need to jump out actually to show you something. But
okay.
So first thing to look at is talking about .NET inline editing. One of the things is we have dramatically increased the size that you could display in the console. And so Lambda functions can be up to 50 meg in size, unzipped. If you add some layers, you can add some more. So, okay, a bit of a nuance over there. But previously in the console, if your whole function package was more than 3 meg, you couldn't view it in the console. So even if you had a tiny little handler file, but you had a dependency or your node modules or your whatever else was bigger than 3 meg, gone. Now that is no longer the case. as long as you're within 50 meg, we can only view a single file. And so that is brilliant. So if we, in fact, look over here, I have added a big file.zip, which does absolutely nothing, but it's just to increase my package size within my Lambda function. And you can see my package size here is 11.2 meg, and I can still view the function. And that is absolutely brilliant, because it is super frustrating when you just go over that 3 meg limit and you can't view it in the console. And of course, all good developers are doing things locally and infrastructure as code and everything. Lots of people start in the console, and that's completely understandable. And it's easy, quick to test things out and try things out. So, off you go. So this is a super helpful thing. Also, it's really good when you're doing, debugging, troubleshooting. You've got some error. Of course, you're going to do your observability tool and look all in that. Or you know what? You're just going to jump to the console, look at the code, see what's happening, and get yourself familiarization with what's going on. Now you can straight in the console. So that's immediately the kind of thing we can look at the larger package size. So this is Visual Studio Code. So I can also I can look at the command palette. So tell me all the kind of things I can do with Lambda. So that's super cool. You can find out all the various kind of things. Same as with local and remote. Then the next thing over here is environment variables are just displayed right over here. So this is super useful that, while I'm developing, while I'm coding, for example, I am referencing my variable here in this function. I don't have to jump to another screen to say, what was that environment variable? It is just available over here. And I can go and then edit the environment variables in the previous normal screen. But at least while I am viewing them, they are all available next to me, which is super useful.
Yeah.
So sorry, things may be a little slower than they normally seem, because I'm streaming at the moment as well. My CPU is going a little insane, so everything does grind slightly to a halt, but I promise you it is still working.
I'm a big fan of the whole fact that this is integrating into every aspect of Lambda. Again, even the test events are here, the environment variables, all of these little things are kind of part here. And you can also deploy and test it straight from the editor.
Exactly. So you don't have to leave and context switch and jump around and do all that kind of thing. So just sort of keeps you all over here. So in fact, why don't we go? Let's see if we'll do it in our full screen mode.
There we go.
So what I can do is I can test this function. So I want to create, but now I'm going to create a new test event. And I am going over here and this is a new test event. I haven't jumped to any kind of screen. Hello service office hours test event. And I can create a test event. Now, what I can do over here is I can then select from one of the, 100-ish, 140-ish plus things that can that a Lambda function can invoke a Lambda function and generate an event that comes from over there. So that's sort of super easy. I can change my parameter. Why don't I do a query string parameter over here, and I can create a test event, and then I can simply invoke the function directly over here. And we can see within the same pane. So I've got code, test event, and the output and the function logs in the same place. I haven't had to jump anywhere else. I haven't had to go to another console. I haven't had to go to CloudWatch. All super useful right in the same place. So the other thing I can do is I can save this as a test event. So I can do that. I can also save this actually as a shareable test event.
Oh, interesting.
And this is cool, because this means that I could share this test event with other users in my account. So normally test events are private because it's for your test. But if you want to share a test event, some other developer or somebody else is also looking at this Lambda function, they can see the test events as well. So that's also another sort of super useful kind of thing. Obviously within here, I could do any kind of a test events that's going to completely break it. I can do any kind of test event I want to send to it in the console. So once we've got our events over here, and I want to invoke the function, I can just invoke directly with that test event from over here. Invoke my function a number of times, and just using the test event, like super easy. I haven't jumped anywhere. I've literally just clicked a play button, which seems seems super cool.
And I want to say that this is a very good, useful thing. Like, it may seem like, okay, sure, everything's in the text editor out in your IDE, but leaving the comfort of your wonderful cozy IDE is something that you don't like to do. I hate switching 100 tabs, so having everything at the same place like this just makes it so much more nicer to troubleshoot and just kind of stay in the flow, which is the thing we're all trying to do.
avoid that context switching, and it just means you sort of focused on what you ran, quickly overdo over here. If I wanted to do, hello from Lambda, serverless office hours, it's just super quick. I can just click on I can just save the button and click on the deploy, and that is now going to deploy my function. It's going to take a few seconds. In fact, that's an interesting thing. It's updating the function. Let me go to my full console editor, and then I can test it again, update from Lambda Service Officer. So, I mean, really quick, try my code, iterate really quickly in the cloud, which we love.
That's amazing, yes.
The other thing, let me just close the test event. The other thing is, you know what, why don't we just do some Gen AI stuff, because that's sort of fun. So I'm just going to paste in something over here, and I am going to invoke Amazon Q to say, I want to get the API gateway query string parameters from the event. So I literally just typed that comment. I'm on Windows, so I did Alt-C, but you do Command-C on a Mac, and it just comes up with this. And I'm like, okay, cool. Const query string parameters equals event query string. So I didn't necessarily know that the query string parameters were within an event from API gateway, so that is super useful. And in fact, I haven't done anything now. I just hit enter, and it suggested, I can add the query string parameters from that constant over there. And you're like, okay, I haven't done anything. That is, that is pretty cool. Certainly helpful for my coding. I can do another deploy, which is going to deploy that successfully, and I can go and I can run the test event again, and you can see where's my query string parameters? Has it not deployed yet? There we go. So, and quite updated. Simply using Amazon Q, I've been able to add the query string parameters, and I typed a comment and I hit tab twice. Now, okay, a small kind of thing, but if you want some bigger code of download this object from S3, can you parse through these messages in a Kafka or Kinesis thing? Can you write this to DynamoDB? Literally any, the Amazon Q is trained on the AWS SDK on huge amounts of internal Amazon code. This is a really good way just to be able to help you out with some Gen AI development. And it's in the console. I haven't needed to turn anything on or off or set up anything. It is just there.
I'm quite interested to see, like, does this pick up any sort of your AWS account? Then that's how it's, or does you use the first free version of Q? I don't really know, because
I think it uses the free version of free version. Well, I mean, I am logged into my account, so I don't know if it infers. That's a good point. Yeah,
there you go.
Good
but
question,
you have this straight out of the box right now inside of your inside of this thing. So if you want to go make some quick changes and do some troubleshooting, you can absolutely do this.
Yeah, definitely. And then the other one, why don't we look at live tail logs? So if I go into, if I go into my debug section over here, I can open. In fact, this API is running.
Okay.
So it said so. This is just hitting the API via a web request. What I can do is I can also open CloudWatch Logs Live Tail. Now, again, could have been a context switch. Of course, I can go to CloudWatch. In fact, there were handy buttons within Lambda to jump to CloudWatch and do all that kind of thing. I could view the logs as you saw before with an invoke in the console, but I don't necessarily want to have to jump to another console. So what I can do here is I can literally just start a CloudWatch Logs Live Tail, and that's going to tail my logs. Now, I need to start it because there is a charge for this is running, because there's a process behind the scenes that is going to run. But, while I'm developing, that is all good. So I'm then going to invoke my API a few times, just click, 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 click over there. And this is going to then, fairly quickly just be able to match the events that match any filters that I have and appear live over here, which should be quick. There we go. As I said, it's a bit slow on the streaming. So that's okay. That's fine. That's useful. But what happens if I actually want to change it? Now, only I'm looking at some kind of things that are doing errors. So, for example, I'm just going to stop and start the stream again. The tail. I'm on the stream. If I stop the stream, that'll be a bad thing. So now what's going to happen over here? It's going to do the same thing, but just automatically filter those events. So this is useful because imagine if you've got other people viewing your Lambda function or other people using your API and they are hitting it remotely, or you've got a tester in another room, or your mum checking out your cool new app. They can be invoking it from somewhere else. I should have a. Weirdly, I don't have an error.
You should. Well, should there be an error?
I should definitely have an error.
You should definitely have an error. Have you deployed your function? You have.
Should have been. It's the same function as before. I haven't misspelled error, have I? No. Oh, well.
No?
Maybe we'll try that again. Gremlins are maybe having fun with us.
But
Normally it comes through.
Yeah, one of the things that I want to say why this is a huge thing, at least for the developer experience here, is that I got stuck in between the Lambda monitoring tab and the CloudWatch log, right? And every time I make a change to my Lambda function, hit the monitoring tab, go to CloudWatch logs, find the appropriate log group, and then just hopefully it's there. And you have to click the little resume button, otherwise it doesn't really do that. And that whole dance just took it out of me. Like, it took it out of me, and
it's another little bit of friction.
Exactly. So having it right here where I can just go ahead and change that console.error to error log, that's just great. So love it.
Yeah.
Love it.
Kudos on the CloudWatch team. So, well, as you can tell, we are not doing canned demos. We are live here in office hours. So yeah, I worked earlier today. So who knows? Yeah. Did you add the error recently? Maybe you didn't. Well, I mean, why don't we
try to deploy it again? You never know. It's
definitely updating. Should go green.
Well, so
I definitely did it because I changed the serverless office hours anyway.
Yeah. So change the filter pattern to just empty. I want to see, does it actually show up in any filter pattern at all?
Yeah,
like,
true. There we go. Weird.
There we go. Okay.
Okay.
Sure.
The error got stuck in the gremlin somewhere.
Okay.
Cool.
Fantastic.
Yeah, so I mean, there you can see we've got a single error line. So you can imagine, a super busy API, thousands of people connecting, and you're getting some, one or two weird, odd requests. You can view that over there, which is cool. So yeah, cool. Thank you for all the help in the chat. I'd filter after the events make it to the UI, did the logs make it to the UI? Well, that's an interesting thing because you actually need to start the live tail before you start generating the logs because it is a live tail. So that slightly won't work, but we got there in the end. So a quick thing before we jump to local is we can actually also download the code in the SAM template. So this is super cool. I started in the console and I'm like, you know what? I do need some serverless best practices here. I actually want to use infrastructure as code. I want to actually use my local IDE. I want to use CloudFormation, all those kind of things. So this is a handy way to just download my application. Is just going to download it in a, let's see if I can grab it as well. Is actually going to download. There we go. Or maybe on another screen. There we go. So this has then downloaded, downloaded the source file and the template, which represents my function. It's got that big file, everything included. I know it's a bit small on the stream, but anyway, that is cool. I would then have everything locally.
That's pretty cool.
One last thing, because I wanted to do that before I switch locally. So of course, there are loads of settings over here. I've got a whole bunch of keyboard shortcuts I can configure. I can look at the extensions, which are key maps and all those kind of things. At the moment, there's a very small curated list of extensions. Things like Amazon Q is built in, and these keyboard shortcuts. But over time, I think directionally, we're sort of hoping that we'll be able to add some more extensions, or you'll be able to load some of your own. But obviously, we're not quite sure how this is all going to work, so I want to get some feedback. So yeah, please let us know what kind of extensions you would like.
Yeah, exactly, chat. If you feel like using this tool is useful, and you feel like you absolutely need this specific extension to make your life better, let us know.
Yeah, definitely. And then the other cool one is obviously the themes. Previously I could, do whatever kind of theme. And so why don't I dark modern default light theme? And like, there we go. Cool. So, I mean, now if that's awesome. If you're normally doing it, in fact, if I go into full screen mode, that's going to look, much more better in my, my dark mode. I think Darko codes in Darko mode. He doesn't do dark mode, but that's the only way we're going to do it.
It is always in Darko mode. I love it.
So why would we did have a question from Simon Highlander? Why would you want to use CF in 2024? Is this CloudFormation, Simon? I'm
going to assume it's CloudFormation. Right?
I'm assuming it's CloudFormation. I'll tell you for good reason. And this is not to. There are lots of other infrastructure as code tools, but CloudFormation is basically the raw assembly code for all of your cloud infrastructure. But it's the raw assembly code for all of your cloud infrastructure. So ultimately, you're going to be using a framework like maybe AWS SAM, or you're going to be using CDK because because that is going to be, that basically generates CloudFormation under the hood, but it's going to be way easier. And so, flippantly, I'll say CloudFormation, but actually if you're using SAM, using CDK, it's generating CloudFormation for you, makes it much easier, and that's going to be great. Your other options, you've got Pulumi, Terraform. I mean, loads of people use Terraform. If you use Terraform to build serverless applications, absolutely brilliant. Go for it. Some of the local stuff works with Terraform as well.
Absolutely.
So in fact, Daryl, you had a comment almost like a new Cloud9, but in the Lambda console. Funnily enough, the old Lambda console was Cloud9 Lite. And so this has in fact taken another jump into be sort of more VS Code-like rather than Cloud9-like. But yeah, thanks, Daryl. Thanks for joining us again.
Yes, absolutely.
So what I'm going to do is I'm then going to jump to my local IDE. And actually, if I just quickly switch between the two, you can sort of see there's not that much of a difference. Of course, I've got a different function running, but the point is, visually, I sort of have a similar look and feel. I could probably get more accurate with it.
I haven't noticed this, but like, does the online IDE have what is it called? A terminal?
No. Good point. So 2 points. You can't debug, and the online doesn't have a terminal because there isn't anything to connect to or SSH into or anything. That is the reason why there isn't a terminal, because Lambda hasn't got any sort of terminal function that you can connect to do that. So, but that is an interesting thought. And, people internally are thinking like, what would it do to create a terminal that could maybe terminal out to some, I don't know, cloud box, EC2 box, whether that would be even useful, who knows? But there isn't a terminal because you can't really run, build things or, Python or Node or Java or commands directly or .NET commands on a terminal because you're in a code editor. So good point. And that's also a limitation of the actual Visual Studio part. You can't do debug, all that kind of thing.
Yeah, that's good.
So let's jump into local. So I now have it's a different application. It's a little Python application. It also has an API. And if I look at my code here, I have, a Python file. I have a requirements to text file, which is just using the request library. And this is a pretty simple little application, checks my IP and, does a response based on the IP. And that's it. Now, the interesting thing is, as we said in the beginning, lots of people are saying, well, Lambda's different and I've got to do things differently in Lambda. And that's a sort of bit of a barrier in everything. But if you're writing Python, Node, Go, Java, Rust, whatever, these are just normal languages that you can use. And yes, Lambda does require basically an event object and a function wrapped around it. But ultimately, it is still the same kind of language. So I'm sitting here with Python. Now, what I've actually done is I've added this main part to my Python function, which a Lambda function wouldn't need. But this actually helps me out, because what I can do is I can, import an event object directly in my main code, and I can use that, and then I could just print out some information. So what would this do? This is basically going to run my Lambda handler. So if I was to run, there we go, Python. Oops, in fact it's Python 3, isn't it? What have I called this? app.py. Oh, helps to go into the source folder. Hey. Oh, hello world.
Okay.
Oh, okay. I'm in a different folder because I'm being. Anyway, what would basically happen is that normal Python file would run. So anyway, that would run. But the other thing I want to show you is I can run and debug this locally. Forget about Lambda. I can just run and debug this using the normal Python current file, and I can then attach a local Python debugger to this, and it works as if you're writing any Python other application. So whether you're building something for EC2 or container or anywhere else or your local machine, I'm going to be able to attach this debugger. So look over here. I now have a body. I've got all my variables. I've got everything over here. I've got my event object. And actually, for a lot of people, even though they're building Lambda functions, they can just build normal Node or Python functions. And some people sort of forget this, that actually you're just using Python, you're just using Node with a little bit of, injecting an event object into that. I've got a normal Python function. And so I can actually use step 3 debugging directly over here. You saw how quick it was to run. Yeah. And then what it's going to do is update it. And so, we've made a lot of enhancements to the local IDE experience, which is beyond this, but that's the Lambda side. But even before then, this is super cool that you can sort of remember that, these are normal Python Node Java functions, and I can just develop them as if I was doing anything normally. And the only difference here is basically this Lambda handler with the event and the consec. I mean, that's the only thing. So, that's a thing to remember for people who sometimes think there's a lot of hoops to jump through to get Lambda going.
Well, I must say that was my main challenge initially when working with Lambda functions, that like you had to tailor your application to be a Lambda function, right? Oh, it has to add this function, it has to receive an event and some context, otherwise it just doesn't work. And if you make too many changes to it, it just doesn't run locally, yada yada yada. So it's good to see this.
Yeah, definitely. But now obviously we do want to get things deployed into the cloud. Right. I can't just run Python deploy or something. I need to deploy this into function. I need to do some build. I have a requirements.txt file, so I'm going to need to build this function. I want to use infrastructure as code, and I want to do all this kind of thing. So as part of the Lambda toolkit, there is a whole new part of the Lambda toolkit called the application builder.
Okay.
And before I show you through the application builder, you can actually launch the application builder over here. And this is going to just give you some advice on getting started. So you can install the AWS CLI, you can install the SAM CLI, and you can install Docker all from over here. This is going to tell me, hopefully I've got them all 3 installed, because I do. But yeah, just a quick way to get some prerequisites going, right in here that you can get started building your application. So the AWS CLI is always going to be helpful for doing kind of things. The SAM CLI is interesting because we're going to show you a whole bunch of things, and you probably aren't going to know that SAM CLI is behind all of it. But it's going to be make things really easy and be able to do local invoke, generate test events, do debug, all that kind of thing. But it's sort of behind the scenes, and that's sort of and just exposing the functionality it can do. So yeah, even if you're not a SAM user, or you use CloudFormation, or you use CDK or that kind of thing, it's worth having the SAM CLI installed, because that's a sort of developer-focused command line utility, which works with a whole bunch of other things, even Terraform and CDK, and that is separate from the SAM framework, which does the CloudFormation abstraction. I appreciate they should hopefully be called they should be called 2 different things, but they're not. So anyway, that's done. I've got some stuff over here where it's going to tell me how I'm going to, in the future, build my code, a walkthrough which just explains all the functionality which we're going to do, and then how to deploy it. So yeah, just a nice little wizard over here that allows you to do kind of things. And what I can do as well is I can start with some sample applications. So if I want to build a REST API, this is going to basically download a whole mini REST API application, or file processing, go from S3, do Lambda resizing and send it to another S3 bucket, and do a whole bunch of kind of things. I can build with a visual builder as well. So I can literally use infrastructure composer, and I can literally just draw out what an application would be and do everything visually. So everything local, some nice getting started steps, and a sort of walkthrough to help you build your application.
That's really cool.
But I already have an application.
Okay.
Yes, Darko, you were gonna.
No. This is really cool. Again, when you're starting with a fresh slate, just like with just your IDE, this is a really great way to get you at least some of the boilerplate stuff done, some of the first steps in, and then you can start editing and creating straight from your IDE.
Yeah. Exactly.
Without having to touch the console at all.
Yeah, exactly. And I know, and you don't have to touch a console, and you don't have to touch the terminal. And this is a controversial statement, because some people I talk to say, why would I ever want to use anything? Everything I do is in the terminal. It's like, yes, if you know what to type. And so, this is that bridge to just make that a little bit easier. If you want to use the terminal, go ahead. That is still great.
You're always going to end up using the terminal. Let me put it that way. You're going to end up using the terminal, but getting there sometimes can be a bit more challenging.
Yes. So what has happened now? I have deployed this before, so some stuff is sort of going a little bit forward, but basically what I have here is this is viewed my Python plain SAM template. So, imagine from the console, I deployed this, or I downloaded it, and it's just going to look at my SAM template and understands I have a Lambda function as part of that SAM template. Great. Okay. If I had an SQS queue or a S3 bucket or that kind of thing, it would also show it in here. So a nice just visual representation of whatever is in my function. So hovering over here, I can open the template file. So you can see this is my AWS SAM template. I'm using Python 3.11. I suppose I could upgrade to 3.13 today. Just shows my template, but a quick way to jump to the template. I can also view this application in Infrastructure Composer. So the previous one, I could generate one. Well, here we go. I can view this application in Infrastructure Composer, which is a really sort of handy way to just get a visual representation. Now, this is a simple app, but if I had S3, few different parts of my stack, this is a really great way to look at that. And I can also then click on, say, a Lambda function, for example, and in this sort of visual thing, I could change this, language runtime to Python 3.13, for example, without having to know that, oh, yes, I've actually got to go into my SAM template over here and, change over these parameters and find out what it is. Yeah. I can just go and do that in the Visual Console, which is super easy.
I love it. I love that thing is part of Visual Studio Code as well. So this is
no, exactly. Just again, I've moved out of the console. I'm not doing anything in the console. It's everything local as well. The next thing I want to do, obviously, is I want to build my application. So I've got dependencies. I want to do that. So all I need to do over here is I need to click on build this SAM template. So and I want to specify some build flags, because what is cool here is there are a whole bunch of options you can use to make to build your functions. Now, if I'm going to be doing a lot of builds, I want to cache the builds and do them in parallel, because that's going to speed things up. I can use a container. So this is actually super useful, because if I, for example, don't have Python even installed on my machine, well, I'm not going to have the Python tools to build something. I can use a container, and it's going to download a Docker container, which has the build tools for all Lambda runtimes and things like Go and all that kind of thing. And not Go, because it's compiled. You do that locally anyway. But yeah, it just makes it easy. So I've done this before, for example, where I have Python 3.11 installed, I think, but I don't have Python 3.12. So if I want to try Python 3.12, I'm going to stop myself here and go, oh, I can't do this in Python 3.12. I've got to download, install Python 3.12. No, just do it inside a container. So I'm going to just take that off, because I don't need that at the moment. I'm going to click OK, and this is then going to go off, and this is going to do basically under the hood a SAM build. But again, you're not going to be able to see sort of anything happening unless you sort of view it over here. And this is then going to build my application. And if I view over here, it is actually going to create a AWS SAM folder where it puts everything, helpfully puts everything in over there. Now, as I said, I am streaming, so my CPU does go a little mad. So this does take long. This is a little bit quicker. It's also what it's going to do super helpfully is actually save the parameters into this TOML file. So each time I do some config, this is going to save all those build parameters. It will update this use container to false, because I changed that. And yeah, just keeps adding all of these kind of things. So you've got all your configuration of how you're going to manage your IDEs all kept in one place. And this is super useful. Also, if you're then moving between projects, it just makes things a bit easier. So I have a configuration file which has all my stuff in here.
I must say that the SAM build or SAM in general is a lifesaver when it comes to building out Lambda functions that have specific requirements and imports you need to do, because packaging those sometimes can be a bit more Byzantine.
Definitely.
Like you're not really sure what you need to do. Where do these things go? Is it a layer? Is it whatnot?
Yeah.
SAM build kind of handles all that for you, so you don't have to worry about a thing.
Yeah. And SAM build's got some cool functionality where you can use make files, you can import out, get outputs from various other kind of stacks, a whole bunch of things. So that, super useful. So this is now built this, and that's all good. So the next thing I probably want to do is I want to deploy the SAM application to the cloud. Now, what I'm actually going to do in the sort of normal way of doing things is I'm going to do a whole CloudFormation deploy. So I'm going to and I'm just going to call this Python plain serverless office hours. And I'm going to specify parameters. Why don't we deploy it in London? So I'm there. I'm going to use the stack name, and I'm going to just put the artifacts in a SAM bucket that's already there. Mm-hmm. And this is then going to do a SAM deploy. Okay. Now, this is nice, but as you see, it's going to do a full CloudFormation deploy. So I have done this before, so it's going to be a little bit quicker.
Okay.
You can see it's found a cache. In fact, it may be even quicker because I probably haven't changed this as well. But ultimately, this is going to go through a CloudFormation deploy. CloudFormation is awesome because it is entirely deterministic. If it's deployed, you always know it's going to work, but it involves uploading something to CloudFormation. CloudFormation has to parse it, has to download it, do all this kind of thing. And sometimes, that is a little frustrating if you literally just have one line change you want to do.
Okay.
So, this is my parameters. So I do have a S3 bucket. So this is going to take a bit of time. Initiating the deployment, says some data exists already. So it's going to be slightly quicker than the first time, but you can already see this isn't the fastest process. But this is what you would do if you're doing a CI/CD process. This is what you're going to do if you're going to deploy something into production or even into UAT testing or this kind of thing, because you know that you can deploy this to multiple accounts, hand this to your developer friends, and it's all going to work. And this is the sort of proper infrastructure as code way of doing things. And obviously you can do that.
Yeah.
So I do then have a value over here for an API. So this is deployed in the cloud. I think I have Postman over here, which should work. So I can look at Postman and I can then invoke this in the cloud. This is my function, and I can just invoke this function in the cloud. Perfect, job done, really easy. But that was a little bit slow. So the other part, which we can do, is another thing called sync. And what sync does is I can do some parameters. I want to do that to London. I'm actually going to use the same stack name. I could probably want to do a different stack name between my development stack, my production stack, and test stack, but we're just doing a test tab here. So here's some other cool things I can do. I could create a Lambda layer for my dependencies. So when I update things, it's going to be quick. And the whole point of SAM sync is it's going to do a CloudFormation deploy, but then every time you change your function code, it just pushes that function code just to the Lambda API. So that's much quicker than doing a whole CloudFormation deploy. And what it's going to do, I'm going to set this watch parameter over here, that's what it's going to do. It's going to watch for my local application, and anytime my file changes, it is going to reflect that. So I can close my SAM deploy. So this is going to then do what's called SAM sync under the hood. Now, again, I haven't needed to type any of the commands. It has just done its, it's just going to do its thing. And this is going to do a sort of slightly different CloudFormation deploy, but hopefully it's going to be pretty quick. And you can see over here, it says it's starting what's called an infrastructure sync. So this is, if I had a, S3 buckets, SQSQ, do all that kind of stuff, because when I'm iterating on my function, on my code, I'm not changing S3 buckets or SQSQs or, the requests dependency or any of that kind of thing. So some things haven't changed because it's the same as the SAM deploy. This is obviously a little bit quick. So this is now in sync with the cloud template.
Right.
So
is this doing like hot swap on your Lambda function? Like, is that the official
It is
term?
going to. So now it's currently waiting for me to do a hot stop. So what I'm going to do is I'm going to change this version back from number 8. What do we have? We had version 8, and I'm going to do version 9, and I'm going to save. So all I'm doing is saving that. I'm not touching anything else. Syncing the Lambda function.
Boom.
It says the cache is I was even going to do this quicker, but what I've selected actually here is using a container to do the build. So obviously it's still going to mount a container to do the build, but we will improve that because but basically that's finished. So already, even doing a container build, that was really quick. So what I'm going to do here, so I'm just going to go back to that config file, and I don't need a container build. I don't need a container for over here. And I'm just going to say that. So why don't we do version 10? Now, hopefully let me just check. Hopefully the SAM sync.
Exactly. Yeah, will this apply? Will it look at the TOML file as
no.
well?
So I need to redo the SAM sync because I think it's not launching the TOML file. But let's just do its thing because it's going to be quick. Actually, we don't need. We'll close that. So let's just do another SAM sync. Seeing it is fairly quick. Sync,
while you're doing that, Ryan Cormack is asking, does sync need SAM? If I have Terraform, do I need to just use the AWS Lambda CLI to get close to that hot swapping?
Hey, Ryan. Nice of you to join us. So yes, sync does need SAM, but you can. I'm trying to remember. That's a good question. If SAM can deploy and do local invokes for Terraform and also for cloud, for CDK things, but I'm not sure if it actually works for Terraform. Yeah. But I wonder. I don't think so, actually, because it is doing a CloudFormation. It needs to have a CloudFormation stack that it's going to deploy with. So yes, I don't think so, but yeah, I know that's definitely on a list of things to do.
Yeah,
Sorry,
I'm looking
Ryan.
if Terraform has a hot. I'm looking if Terraform has like a hot swap feature, but I don't think they do. So
and CDK has its own hot swap feature as well, called CDK Watch. So yeah,
CDK Watch. Yep.
So really, I don't think I did. I don't think I had the watch thing on. We will get there. Python plain. Sam the bucket. Watch. I don't. So let's just do that. Another deploy.
I guess this is just a really fast way to iterate over code, because ultimately what you want to achieve as a developer is the fastest return time from your code changes to the actual output, right? There's nothing more depressing when you're debugging some code and then you make a change and you deploy and you have to wait for like 7 minutes and then like try the same issue. So absolutely what you need is the ability to quickly iterate on code changes, and this is definitely the thing that gets you going.
Definitely. So because I messed up that container thing, I'm sort of having to start again with the sync. But the thing is, once you've done the sync once, then it's going to be really quickly, and I will get that working, that we can show that. So this is just updating. So it does initial CloudFormation sync.
Yeah, Itali's asking, I'm very new to building with VS Code and Lambda. Do you have a video that explains that from zero? Is there something that we can...
Yes, in fact, there will be a 5-minute demo coming out. It's not quite out yet, but on the AWS Developers YouTube channel. It has been all recorded. It's currently in editing. So yes, that will be coming out. Yeah.
I'll share the link. So
cool. So we have a stack. The infrastructure is complete. So what I'm going to do is, what version do we want? I'm going to do version 12. And now I'm just going to hit save and syncing Lambda function, postname function. And it's just going to quickly copy up the file, upload it to the Lambda API. Done. So what was that? 4 or 5 seconds. And if I was then to go over here and invoke my function, where's my raw output? There we go. It's weirdly the pretty output doesn't work. So there we go. So I've got version 12, invoke it a few times. I want to then change this, whatever code. I'm just making a silly version change. You can see over here, I'm just going to save the file, syncing, does a quick build, copies up the files, and then sends it off to Lambda, and that is done. I can then go over to here, and I can invoke that as well. So, I mean, that's really quick. And the cool thing is I'm actually invoking in the cloud. So I'm not mocking any dependencies or doing anything. I'm actually doing a cloud invoke. So the cloud invoke is cool, but also often people want to actually do things locally, and they do want to iterate on their function locally. And this could be a cost concern because they don't want to run costs up in the cloud, or things, some other resources take a while to deploy. And you just want to do more things locally. So as part of this over here, once this is deployed, I'm able to look at this function, and I can obviously look at the code over here locally as well. But the cool thing is I can then open up this new local invoke and debug configuration. And this allows me to, very similar to the console, to be able to pick an event object. So I've got this event object over here, which is just a JSON file, which is the event. I can set some parameters in this kind of thing, and I can locally invoke it and also debug it. So remember before I could just do the Python debugging, that all works great, but this is actually now debugging within a Lambda a mock Lambda environment by default. So what this is going to do is actually going to download another Docker container, which is sort of pretend version of the whole Lambda runtime. And so this is going to run the Docker container. It's going to do a build again. Oh, I'm just flicking through all the logs that's happening. And so, it's going to automatically download it. If I was using Python 11, 12, 13, it's going to download whatever images is available for that. And because now I also have a a breakpoint within this code, remember it's the same breakpoint I had for Python, it's actually going to attach the debugger not to the Python debugger, but actually to the Docker container for my Lambda for my Lambda function. So this allows me to more accurately test things working within Lambda. Do I have a misformed event object, or have I written something in my code that is going to, try write to the operating system, or that kind of thing? It's going to check my dependencies within my Lambda function, maybe talk to other kind of things and all that kind of thing. So we are getting there.
So Julian, would this work with any Lambda runtime?
Yes.
Yes. Okay, that's it. Also good. So whether you're developing in .NET or in Python, or in whatever.
Let me caveat. I believe a lot of them manage runtimes. So for instance, you can't do step-through debugging in a Lambda runtime environment for, say, Go or Rust or those kind of things. So I believe it's Python, Node, .NET, and Java, I believe, which all support the local. If somebody is watching, and I'm wrong with that.
Unfortunately, no Rust. Even this managed editor on the console doesn't work with Rust.
Yeah, because it's a compiled binary, so there's actually no visibility inside the compiled binary. So this is cool. Look here, I have the event object and I have the context object literally sitting over here, and I am inside a Lambda environment, but it looks just like a normal debugger, and I can step through my code. And there we go. I didn't have to run any weird commands locally to set this all up. I've got local debug all set up within my application. And what I can do is I can also, I had previously saved this debug configuration, but there are a lot of different parameters you can do. You can load in external environment variables, event objects, and all this kind of thing. And ultimately, as with all things with in VS Code, this is just storing it in your launch JSON.config. So yeah, I can view this over here. I can, where's my config? Look at all these kind of things, and I am doing local. Local testing my function. So what I'd do is I'd normally do this before I even deploy it to the cloud, but I wanted to show you the sync that's a cloud version, but the local version, really works, and everything is over here. Some other quick things, because I know we are running out of time, is if I can look at the function over here, which is deploying, and I can, this will update. And actually I can do the same thing, but for a remote, debugging.
You can pull. You can pull a remote function, right? You should be able to pull a remote function locally. Yeah, nice.
So invoke in the cloud, so I can do the same kind of thing. Select local file, choose that event object I had locally, events, event.json, and then I'm going to remote invoke. And again, so now this is in my local IDE. I'm calling the Lambda API to remotely invoke. And this is not, there we go. So I now have my version 13. I can remotely invoke this as many times as I like. I haven't gone to the console. I've got the event object over here. And the last little thing, which is pretty cool, two last things, is I can also look at my cloud function and copy the URL name on, all these kind of things. The other cool little thing I can do is I can just look at the logs, and so I can look at the last 15 minutes of logs. I could look at error logs or whatever, this kind of thing. I'm going to do all kind of things, but there we go. I've just pulled the Lambda logs directly from CloudWatch directly over here. So if someone else who was testing it via an API or via Postman, I'm obviously not going to see the Lambda logs locally here for my invocation. And I have then the Lambda logs directly in my IDE. So I have an existing function. I've done local debug, step-through debugging in the language runtime. I've done step-through debugging within the Lambda, within the actual Lambda runtime environment. I can build using Docker containers for a whole bunch of things. I can deploy it to the cloud. I can locally invoke. I can do quick and dirty syncs to iterate over my things. I can do full CloudFormation syncs, everything within my local IDE, and I haven't had to, and looked at logs, and I haven't had to step anywhere else.
So many things without ever stepping out of the IDE, which is the best part of this whole thing.
No, absolutely.
And I think this is kind of the pattern you're going to see going forward. Is you're going to see a lot of more developer experience improvements for folks building with Lambda functions. So any sort of feedback, any sort of things you have on your wish list that you would love, yell at Julian, yell at me, yell at us. We'd love to take this feedback over to the service teams.
And as Darko says, it's early days. There's still a lot more to do. I mean, I had a few glitches that went over here. So if you're looking, going, oh, that seemed a little convoluted and going around, a lot of that's on me. So you can blame me that I clicked on the wrong things and messed up some kind of stuff. But it is actually quite simple and intuitive. And this whole new application builder is super cool, just to be able to view everything that's going on in your application.
I love it. I love it. Awesome.
Darko, thanks for having me. Yeah,
Thank
time
you
is
for having me, I guess.
time is running up. But yeah, same time, same place next week. We're actually going to do pre-invent. So we're going to be talking about everything going on at reInvent and all the announcements. And we're going to have a whole chaotic group of people. ECS and Lambda's 10-year birthday. That was last week's stream. That was great fun talking to lots of people about that. So thank you very much, everybody. Goodbye.
Thank you, folks. See ya. Bye.